Assalamualaikum warahmatullahi wabarakatuh, and very good day to everyone. So today we are going to discuss the solution for the first test that was conducted a few weeks ago, and hopefully we all will learn something from this discussion. Okay, all right. So again, this is the first test for ENT243 as well as MMJ22403 thermodynamics 2 for this academic session, semester 1, 2021-2022. Okay, so let's go to, before we go into details, I have a few notes that I would like to share with students. Okay, so upon grading the test, and I noticed there are several things that needs to be improved in order for students to better answer or better understood the materials learned, okay, in the class, okay, and basically to better prepare for the final exam. And I do hope that this discussion will provide some insights on what is to be expected for your final examination soon. Okay, so my first comment: basic instructions not followed. So as simple as writing down the numbers. Okay, so there is a reason for that, which I'm not going to discuss here, but the instructions are very, very simple, and I've basically asked students, I've given instructions in the Google Classroom before the test as well as during the test itself. And so I was expecting students to comply with that. Unfortunately, some students, minority of the students, did not write down the attendance number, even though I've asked them to do so. Okay, so that's first one. And second one, some students even submitted their answer sheets without being binded or without being stapled. And if one of the sheets went missing, then you will have trouble because you will lose mark. Okay, I will grade. Well, fortunately, I managed to find that the pair, so that particular student was safe. Otherwise, okay, he or she might have to be content with whatever marks that he or she got based on the paper that I can find. All right. And for the next point, so in your answer sheet, please, please, please write the question number clearly. So right now in test one, we only had two questions, question one and question two. But some students basically just jumble up both questions in their answer sheets, okay, making it very, very difficult for me to find the answer and to give you marks, basically. So please, in the next test, final exam, make sure you indicate clearly at the top of the page the questions that you are trying to solve. Okay, for the next one, arrange your answer, basically your steps and procedures properly and clearly so that the lecturers, myself and Dr. Nama, can follow this sequence. Some of the answers given by students is just almost impossible for me to find the answers because they are all mixed from question D, suddenly question A, and then go back to C, and then finally E. I understand that you are racing against the time, yes, but in order for me to give you the appropriate or corresponding points that you deserve, I think you need to do your part to help me by structuring your answers carefully. Okay, so label or show your steps clearly, step 1, step 2, step 3. If your answers or if the question involve a lot of calculations, my suggestion is to separate the sheet into two sections. For example, okay, if this is your sheet, okay, so allocate the right portion of the paper for calculation and the other part for your steps or procedure. When you do that, it will make it easy for me to follow the procedure, while over here you have all the details in the calculation. Okay. Next, and please, because for each questions, there is a part A, part B, part C, or part D, or question 1A, 1B, 1C, and 1D. So please help your grader to find your answer easily by underlining or circling your answer. So for example, let's say the answer for question 1B, for example, T3 equal to 1000 Kelvin. Let's say this is the answer. So please either underline your answer, or better yet, make a circle so that I can quickly identify that this is the answer for question 1B, for example. Okay, all right. So next, unfortunately, again, I think I've mentioned this during the test, issues with using pencil. There is a reason why I asked students to use pen in submitting the answer sheets. Okay, among the reasons are, first one, possibility that your answers might be smudged, okay, or accidentally erased upon submission. That's the first one, and that's a very, very valid reason. And the second reason is that there is also a possibility of students changing their answers upon receiving the graded paper. And this has happened before. So please make sure you use pen when answering your final exam or any other test. Okay. The next reason, or the next issues that I found when grading this paper, is that students did not read the questions properly. For example, in question 1, students are required to use the exact analysis, okay, which we are going to look in a bit. But so many students basically use approximate analysis to answer the first question. Okay, they, or the students, most of the students did not look at the keywords given, which is considering the variation of the specific heat with temperature. So this is the big issue. When you did not give the answers required by the question, you lose mark. It is as simple as that. Okay, so please read the question carefully. Take your time to read the question. Okay, and in question 2, which is the diesel cycle, some students still using isentropic equation between process 2 and 3. Okay, we are going to look into detail in a bit, but 1, 2, 3, 4. Okay. If you look over here, isentropic process is from 1 to 2 and 3 to 4. So if you use isentropic equations for this region, 2 and 3, then you got the steps wrong. Okay, so please, I keep on emphasizing this in the class, in the tutorial. Understand when to use that particular equation. Okay. Next one. Okay. Other issues regarding the test is that students still did not draw appropriate diagram. And I've told you so many times in the class as well as in the tutorial, in order for you to answer the questions properly or correctly, a good diagram is needed. And not just a diagram, all the labels must be presented as well. Okay, the labels here basically is the information that were extracted from the questions and then put in the diagram properly. So that's what I meant by a proper diagram, not just, for example, you just draw a diagram like this. Okay, this is for diesel cycle. No, it needs to be accompanied by relevant information from the given question. Okay. So again, I have highlighted over here, you need all the labels okay, basically transferring the info from the questions to the diagram. Okay. The other issues is regarding the units. I've told students so many times, units are very, very important. Okay. It differentiates or give meanings to the answers. Kilopascal and kilojoule, they are two different things, for example. Okay. Without a proper unit, your answers basically is meaningless. So that's why basically students who did not write a proper unit, okay, will have their marks or their grades deducted. Okay. So hopefully you pay attention to that. And finally, regarding the critical analysis question. Okay. I've mentioned in the class the way that the questions were to be structured or were structured. Basically, it involved calculations as well as the theoretical parts that basically test your understanding of the content that we learn in the class. So, the question that were given, usually I have part A, B, and C is for calculation, and then D is the critical analysis part. Students need to relate how the questions or how the given question in the critical analysis part can be related or can be used to solve or can be used to address the issues that was given in the problem. So that's why it's important for you to understand both the theoretical part, okay, which usually is the fundamentals, okay, from the theory and from the textbook, as well as the calculation part. And most students, unfortunately, fail to give a satisfactory answer, okay, because they did not look at the marks given. For example, both questions have the critical analysis part, and both questions in part question 1D and question 2D, 4 marks were given for each of the critical analysis question. So hence we have 8 marks in total. So 4 marks for each question means I expect some details were given and some analysis or discussion to be accompanied, to be given, okay, for the answers that you give. For example, when we talk about knocking, okay, or auto ignition, okay, first maybe you need to explain what is auto ignition or knocking and what causes auto ignition, okay, and how that impact the engine or the function of the cycle. If you do that, then you get 4 marks. But if your answer was just no, it will have no impact. It will impact, but just a little bit. It will not have a huge influence on the cycle, for example. If that's your answer, then unfortunately, the most that you can get probably just 1 mark, okay, or maybe no marks at all. So please look at the grades or the corresponding marks given for that particular question. Okay, so let's proceed quickly, okay, for question number 1. So I believe all of you have the copy of the question with you. So this is the first question. Okay, basically it is a smart ignition gasoline engine with the details given. And for the first question, the keywords that you need to pay attention is this: variation of specific heats with temperature. So this basically requires you to use the exact analysis. So you are supposed to solve the following problems. A, find the highest temperature and pressure. B, find the thermal efficiency. Basically, okay, if you look at the question, is the thermal efficiency of this car as claimed by the company? To answer this question, basically, you need to find the thermal efficiency based on the given information. Once you find that, then you can compare the two, the calculated thermal efficiency based on the given info, and the one that is claimed by the company. That's where you need to do the comparison. Okay? And For C, you need to calculate the MEP. Okay, I'm going to highlight over here. The name itself is mean effective pressure. And unfortunately, many students did not write down the units. Hence, the answers that they have given in the test for MEP basically is other than the pressure unit, which is kilopascal. So we'll have a look later. And of course, the final part, the final question for question 1, D, you are given a scenario and you need to discuss whether the suggestion given by the CEO should be followed or not. So this is the discussion. The keyword is discuss, and also the marks given was 4. Discuss means not just a one-line sentence. Discuss means you need to have a point and you need to have elaboration, at least 2 or 3 points. Okay, plus elaboration. Then you'll get 4. It is not a one-sentence answer. Okay, so let's quickly go through the solution. Okay. So the first part for auto cycle is for you to draw the to draw the auto cycles diagram, and you need basically to translate or to put the information given into the diagram. Okay? That's how you get 1 mark. So in this test, however, so many students just drew the diagram without the info here. Okay, but I still give points for you guys to help you. To be honest, I'm helping you a lot, which you will see later on when you get the papers. But in the final, complete diagram means you have the appropriate or the correct diagram plus the information that comes with the question. Okay, so this is what's given, and you have to translate or to put that information into the diagram. So the first part, you need to find the highest pressure and temperature. So that's why the diagram is important. By looking at the diagram, you can see that the highest pressure and temperature basically is at state 3. Okay, so to proceed, we'll start with process 1 to 2, which is the isentropic compression. So at temperature 1, which is given, okay, and by using table A17, so I'm using estimated value over here. Okay, remember, I do not look at the final answers per se. I look at the details or the procedures that you written. Because we have 100 plus students, it's almost impossible to get the exact answers for all students. So that's why steps or procedures are more important than the final or the values that you give. Okay? So from T1, from table A17 at T1, you'll get the U1, okay, and also the relative volume for T1. Okay? So you do that, you get 1 mark. Once you get that, okay, you can get VR2 or relative volume 2, okay, by using these corresponding equations, okay, because the specific volume, we know the relationship between specific volume and also the relative volume. So over here, if you look here, V2 over V1, that's, we know, is 1 over R, and we just found VR1 from the tables. So substitute the value, you'll get your VR2 73.08, roughly about that value. So from there, now you can interpolate from table A17 to get T2, which is this corresponding value, 690 Kelvin. Okay, now let's proceed. From there, you can find pressure 2 by using the ideal gas equation. Okay? So you rearrange that, you get P2, substituting all the values. We know this. So that's why it's important to write down properly. So for example, over here, if you notice, I wrote down in details the relationship given to us from the questions. Okay, what is the compression ratio, and what is the relationship between R2 and also R1. So all that is being translated in the diagram. So let's go back over here. So again, if you look over here, we know V1 and V2, that's the compression ratio. Okay, we know T2 and T1, just calculated, okay, from the tables, and we know what is P1. Substitute everything, you get your P2. Okay, next, process 223. This is the constant heat addition process. Remember, you cannot use isentropic equations over here because it is not isentropic process. Okay, so we know that Q in can be calculated by U3 minus U1. Okay, and we know from before what is U2 because we get that from the table, and we are given the Q in, which is 830 kilojoule per kilogram. So rearranging everything, you get your U3, then again interpolate, then you will get roughly your T3 is about 1640 kilograms, roughly about that value. So now you get the highest temperature. Okay, but we are not done yet. We need to find the highest pressure as well. So remember, we are still at 2 to 3, so which is a constant volume heat addition process. So we can use the ideal gas equation again. Rearranging, find P3. Okay, we have these two values. Okay, we have also P2. Substituting everything, you'll get your answers 4,300 something kilopascal. Okay, remember, I'm not looking at the final values. I'm looking at the steps. So that's how you get P3 and also T3. Okay, don't forget to circle your answers. Okay, to indicate this is your answers for that particular question. So next, let's proceed. To calculate the thermal efficiency, okay, first we need to understand what are the variables needed to find to calculate the thermal efficiency. Okay, so if you look over here, thermal efficiency requires us to find W net divided by Q in, and Q in here, that's already given. So you need to find W net, and W net is just Q in minus Q out. This is given, but we don't know Q out, so we have to find that. So let's continue with 3 to 4, which is isentropic expansion. Okay, again, this particular relationship, specific volume with the relative volume. So rearranging, we know what is R, compression ratio. Okay, VR3, basically, we need to find or interpolate from before because we know from P3 or T3, okay, we can get this value. Okay, so from here, we get our VR4. Okay, but we require T4. So again, you have to interpolate to get T4 and U4. Okay, so if you proceed with Q out, U4 minus U1, now we have U4, and from previous interpolation, we get U1. So now you have Q out, then you can calculate W net, substitute in the thermal efficiency equation, roughly you'll get about 53%. Okay, so now you make a comparison, the actual thermal efficiency is less than the one claimed by the CEO. Okay. Some students might question, is it possible for us to use this particular equation? In this particular case, no, because this is approximate analysis. So if you use this equation to answer that question 1B, which is to find thermal efficiency, you basically ignoring the keywords, which is to take into account the variation of specific heats. Okay, so you are not answering the question. Okay, so you cannot use this. Okay. So finally, for MEP, okay, MEP is very straightforward. However, some students still have difficulty to solve this particular equation. So MEP basically can be simplified to be the following equations. Okay, W net divided by T volume, okay, 1 minus 1 over R. And all you need to do is just to calculate the volume. And the volume can be calculated by using the ideal gas equation, we can find this from the table. We know what is T1 and we know what is P1. So substitute, make sure units must be written. If you did not write down the units over here as well as over here, you'll get the marks will be deducted. Okay? So from here, then you can substitute your V1 over here. You have all the other information, R for example, and also the W net from before. And this is the unit conversion. If you did not write down the units, then you will forget the unit conversion. That's why your answer will not be in kilopascal. So many students give the answers in, for example, kilojoule over kilogram, which does not make sense because we are dealing with mean effective pressure. When we're talking about pressure, it has to be in Pascal. Okay, so that's why it's very, very important to write down the unit as well as the unit conversion. Okay, so final questions, basically, you need to discuss. Okay, over here, I'm giving you in terms of bullet points. Okay, you can give in terms of bullet points, but just not one simple one-liner or one just yes, no answer. That is not acceptable. Okay, so I'm quite open to any discussion. So if you notice, if you write down anything, as long as it makes sense, it relates to what we learned in the class, I will accept your answers. Okay, unless your answer basically does not make sense at all, or basically way off from what we have learned, then I cannot accept your answer. Otherwise, I'm quite open to any discussion that you wrote down in your answer for question 1D. Okay, so for example, you can make discussions such as the common compression ratio for gasoline engine is 8 to 12. That's the standard one. Okay, so is it possible to increase to 13? Your answer can be yes or no. If yes, for example, you can do it by increasing the bore diameter, okay, or you can use turbo charger. That's one simple example. If your answer was no, then just give a reason why. So any basically valid reason or something logical will be accepted. Okay, I'm not very strict on that. I just want to see whether you understand the concept or the fundamental that we learned in the class. Okay. All right. So that's for question 1. So let's move to question 2. Okay. Again, question 2 is what we learned in CO1. Just now we talked about auto. Now we have the compression ignition diesel engine. Okay. Now over here, I did not specify the keywords, or I did not specify whether to use exact analysis or the approximate analysis. So as I said, if it's not indicated, you are free to use whatever method that you want. And in this case, my suggestion is to proceed with the approximate analysis, okay, because it is quicker. All right. So you are supposed to answer A, B, C, and D, right? So the structure of this question is quite similar to before. You need to find the highest temperature and pressure. You need to find the thermal efficiency, calculate the MEP, and finally discussion. Okay. All right. So let's have a look at the solution. Again, this is given. Oh, sorry. So this is given, and you need to translate or to put this information into the diagram. Only then you'll get the whole mark. All right. So you translate, you get 120 over here, and the relationship between the volume, specific volume. Okay. So for part A, find the highest temperature and pressure. So you need to go back to your diagram. So the highest temperature and pressure in this case would be at state 3. So now we are using the approximate analysis, okay, which is by using the isentropic equation. So remember, the equations are given in the appendix, so you don't have to memorize. To find T2, you can get about 930 Kelvin. P2, you get 120 kilopascal. Yeah, sorry, about 6,000 kilopascal. But from the diagram, you know that P2 is equals to P3, then it should be, the answer should be the same as P2, which is 6,300 something. Okay? So just by using two equations, you already solved half of the question asked. Okay. Okay. So now, again, to find T3, okay, we can find T3 by using this particular relationship. Okay. If you notice over here, T3 and T2, go back to diagram, not isentropic. So what you need to do is you need to use the ideal case equation. So rearrange, you'll get this particular relationship. Okay? So from here you can get T3, which is about 2700 Kelvin. Next, we proceed. We can find Q in. Okay, so for Q in, we know it is at a constant pressure, so we can use this particular or useful equation. You can use H3 and H2. It's not a problem, but it is longer and it is more tedious because you need to refer to the property tables. But we know that H3 and H2 can be simplified because it's a constant pressure process to Cp T3 minus T2. Okay, so you substitute everything, you get your Q in. Next, 3 to 4 is isentropic process. You can use approximate analysis now. You can get T4. Okay, but now if you notice, I give you 3 marks. Okay, so over here, 3 marks are given. Okay, why? Because it's a bit tricky. So now, if you look over here, V3 over V4, majority of the students, they try to find out the real value or the exact value of the volume 3 and volume 4 in order to solve this particular problem. However, if you go back to your diagram and you look carefully, okay, you should see that you can equate, okay, V3 equals to 3V2 based on the information given. Okay, remember, because if you go back to the question, okay, the cut-off ratio was given. So that's why I say it's very, very important for students first to understand the fundamentals learned in the class, and the most important part before you start answering the questions is to transfer the information into the diagram. So if you did not write this, chances are you will not be able to answer correctly this part. So from here, you see that we know V3 equals to 3V2. So if you go back here, so we know that, let's change color, V3 equals to 3V2, and we know that V4 is equals to V1. So if you substitute that in this equation, what you'll have is V2 divided by V1. And we know that V2 is equals to V1 divided by 17. So if you simplify, what you'll get is just 3 multiplied by 1 over 17. So that's why I give 3 marks over here for students who really understand the process or the simplifications based on the diagram. So I repeat, V3 here is based on the cut-off ratio. So V3 equals to 3V2. And we know that V4 equals to V1. So if you put this simplification in the equation, you'll get 3V2 divided by V1 over here. And when you simplify again, you'll get 3, okay, this is 3, multiplied by 1 over 17, because V2 divided by V1 equals to 1 over 17. So if you cancel out everything, calculate, you'll get your T4 equals to about 1,300 or close to 1,400 Kelvin. So there should be a unit K over here. Okay. So that's the tips. That's why it's important for you to translate the information given into the diagram. Okay. So let's proceed. Next, we can find Q out. Again, be careful, guys. Q in is equal to CP33 minus T2. CP because it is a constant pressure process. Q out, we go back quickly. Q out is a constant volume process. Constant volume, constant pressure. So make sure you understand when to use that particular equation. Okay. All right. So Q out is U4 minus U1, or it can be simplified CV T4 minus T1. Okay. Substitute all the values, and we know the thermal efficiency equation. Okay. You can get your answers roughly about 58%. Now, here's the trick, or it's not a trick, but something to ponder. What if you use, let's go to appendix, this particular equation? Is it possible for you to use for question 2, for you to use this approximate analysis? The answer is yes. If you use this equation, you'll get the full mark. Okay. So, some might wonder, is it fair for students? Okay, so I'm going to make it a bit smaller. All right, so over here, if you use this particular method, which is the W net divided by Q in, so you have to calculate the Q in, the Q out, all the details you have to make interpolation is quite detailed. But students who use the approximate analysis, the equations from the appendix, will get the same full mark. Okay. But there's a tips, or there's a trick. If you use this particular equation, of course you get full mark. Okay, and it will help you to answer question 2C easily, because you need to calculate W net as well over here. For those who use the approximate method over here, okay, which is from the appendix, you may have a shortcut. You may have to calculate, you can calculate the thermal efficiency easily, but still over here, you need to calculate W net. So which is the same. So those who use the shortcut, which is the approximate analysis, still need to calculate the W net. So you Q in and Q out over here as well. So either way, it's a win-win situation. Okay, all right. So you have to calculate W net either way. Okay. So for C MEP, again similar to before, we just need to calculate the volume. So from here, we can calculate the volume. Oh, sorry. Let's go back. Sorry. This is question 2. Okay. So again, we can calculate the volume, okay, from the ideal gas equation. Okay, so we know this from the table given to us. You get your V, and then again, I would like to emphasize over here, units, very, very important. Otherwise, marks will be deducted. Okay, so substitute everything, your V, okay, everything. Make sure this is at the unit conversion. You have all this, then you get your answers about 1,600 kilopascal. Mean effective pressure in kilopascal. If you forgot to write down the units, your answers definitely will be in terms of kilojoule or kilojoule per kilogram. Okay. So finally, for question D, what happens if you accidentally use the gasoline or petrol in the diesel engine? Okay. Any answers again are acceptable as long as it is logical and it relates to the fundamental or the content that we covered in the class. So among the answers that I can accept, for example, you have to state diesel engine uses higher compression ratio, but if you use petrol, premature ignition will happen. Okay, because remember, gasoline or petrol engine or petrol have a very or have a lower compression compared to the diesel engine. So before reaching the top dead center, auto ignition already happened. So if this happens a lot or at a long period of time, it will cause engine to break down, since the uneven convection happening in each piston chamber have a different chamber timing. And I can relate to this question because long ago, when I was on a road trip with my family, this happened actually. So we accidentally refill our diesel car or diesel engine with a petrol, or gasoline. So the car moved for a while. Okay, I was under the assumption now the probably because there are still diesel fuel remaining, so that's why we can move for about a few kilometers. But suddenly the engine just broke down. Fortunately, no damage was detected, so we just need to basically remove the gasoline from the engine, and then we have to top up with diesel. And fortunately, the car basically moved again after that. So I think that's because the fuel basically the diesel, basically the remaining diesel is not that much, so that's why the car stops after a while. But if you, for example, still have a lot of diesel fuel, and then you top up with petrol, then the petrol plus the diesel will cause basically uneven combustion along the way for a longer period. Then the car will definitely break down and damage the engine. Okay, so this is again from experience. All right, so overall, how do you think you did in the first test? Okay, so I would like to share with you. This is the prelim output or prelim result for test 1. Okay, this is a combination of for both Thermo 2, MMJ22403 as well as ENT243. In total, out of 133 students registered, you can see that F, this is not fail. It's not just conditional pass or just fail. F, we are talking about F. Almost 27% fail who got or who obtained F grade. If you consider fail, which is from D, D minus, and F, so roughly we have about 36% of the class basically who failed test 1. So you might say, oh, test 1 is only 10%, so I still have time to study for the final. Usually, the tests are a good indicator on how you will perform in the final. In the final, basically it's 60% of your grade. If this is the indicator, then those in this region should be worried, really, really worried. Okay? Because right now, even you have access to recorded lectures, I think students just were not prepared during the test. I was so surprised when I see the answers. Some students basically did not even try or did not even bother to answer the question, did not even bother to try to answer the questions. It was as if you were looking at the questions for the first time. Okay, obviously the questions is not the same as the one we did in the tutorial, but the fundamentals are the same. So that's why I'm quite frustrated because previously the issues with students, they said, oh, when you didn't go to the class, you have no idea what was being covered, so you have trouble to study by yourself. But now you have access to recorded lectures, recorded video, where basically you can study or revise or go back to the lectures whenever that you want before the test. Unfortunately, I think students just did not prepare that well for the test. So again, I think you know where you are. Okay, the results I think will be released by week 12 as requested by the faculty. So right now I just can't really release or give the papers back to you guys. So you have to wait, but I think based on the answers, based on the discussion just now, you know where you are. So overall, we only have about 70% who got A. Okay, majority F. Okay, so something to ponder. Okay, where you are, if you know you are in this region, what will you do? Any corrective actions? It's all up to you. If you have any question, you can come and see Dr. Nama and myself. But unfortunately, I don't have any visitors or any students visiting or asking any questions throughout the semester. So yeah, again, I think that's all that I want to cover. I've discussed basically the answers. I've discussed the steps, what to be expected. Pretty much the same for the final, actually. Okay. So of course the final will be a different questions, but the structure will be the same. Critical analysis, calculations, um, units, okay, all that stuff. So I think this is very, very important. This part here. All right. So I hope that you get something from our discussion today, and I don't know, pay attention, do something, okay, study harder, okay? Or ask questions if you got any. Okay, it's very, very important. If you don't understand something in the lecture, please ask questions. Okay, so with that, thank you for your time. Thank you for your attention. I'll see you all soon. Okay, Assalamualaikum. A very good day, everyone.